And recording. We're going to create the finger pulls or the handles down here in the bottom of the actual top for the lathe roll around cart. This area here I've got is 1200 wide. This is across the x-axis, and the y-axis is 650 millimeters. Thickness is 18. I have already done all of this stuff over on the side here. We'll say okay. Now I want to create a couple of finger pulls. I know the distances across they've got to be, the center of this finger pull has got to be 295 from the left, and they've got to be 30 millimeters but wide, but, or high could I say, but 40 millimeters to the center. The quickest way is to create a rectangle, and I'm going to say 295, and I already have 40 millimeters up the page to where I want it to be. The width is 90 millimeters. Overall, it's going to be 120 when I finish. But it's seeing I've got a 30 millimeter width or height of these holes, or the handle slots. They will have a radius of 15 millimeters either end. So 90 plus 30, which is 2 times 15, obviously, will give me 120 wide for the total width of these handle slots. So I'm going to click create, and it's thrown one down the bottom of the screen. The other one I want to be across 832 millimeters according to my measurements. Same height up the screen, which is 40 millimeters. Oh, you'll notice that I've got the center of the rectangle is highlighted here. That's where it's going to put it. I'm not going to put it on the left or the right hand side. In other words, the rectangle won't jump off from the left and go right. It will be center. Let's hit create again, and there's the other one popped up. Lovely. Close that. I'm going to increase the size of the screen a little and make it a bit easier to see. We're going to work on this particular one here. Create a circle, and it's a 30 millimeter diameter. I'm not going to tell it where to go. I'm going to put it there. See up the top here, I have got snap to grids and all that kind of snap to geometry. It says that's the center of that line, that vertical line on the y-axis. Let's put the circle there, Dave. And I've said, by all means, let's do it over there as well. And we'll slide across to the other rectangle and say, put the circle there and the circle there. And now we'll say close. We're finished with all that. We're going to put all the vectors to sleep by just left clicking on the screen. Now I'm going to get the scissors and say goodbye to some of these lines that we don't want. And you'll notice now if I close the scissors and click one part of this vector, the whole thing has been welded together. That is one full vector, a new vector made from many. There we go. That's what it used to look like. Get the scissors again, and we can click, 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 and we'll just check that it's also working as a full vector. All of it's woken up. All right, next thing to do is to go from the drawing, so this is computer-aided design or computer-aided drawing, over to the other side here. We'll throw up that menu, and this is computer-aided machining, or this is CAM. The other one was CAD, you'll know it. This one is CAM. All right, let's wake up the pair of the vectors by left-clicking on the screen and saying, hello, there they are. I'm going to select a toolpath operation, and this particular one will be the profile toolpath that lets me cut on, inside, or outside a vector. I've already set this up to go 18.2 millimeters, which is going to go 0.2 of a millimeter through the back of the board. I do want these to be totally released at the end. We're going to go through in 4 passes. We do have a 1/4 inch end mill selected. I'll go to select and I'll show you the details of that. It will be spinning at 18,000 RPM. It will travel at 6 meters a minute. Its plunge rate will be 300 millimeters in a minute, so it will go down 1 foot in a minute's time, or over a minute. There's the end mill. Everything's set there. That's fine. All good. Okay, so we just say select. Now, I want it to go on the inside of the vector. So if we make this a little bit bigger so we can see what's happening here, drag it back over this way. I want the cutter to be working on the inside of the vector, and I'm also wanting it to do what's called a climb cut. Or should I do a conventional? If I'm going on the inside and it's turning this direction, it's going to want to chip everything out. If it's going this direction, going counterclockwise, it's coming down into the material, and then this part here has already been cut, so it's fine. It's not going to be chipping out. So this will give me a cleaner cut if I do this, what's called climb. Now I need to add some tabs to the toolpaths, and I want them to be 2.5 millimeters deep. The tabs are basically the things that I leave in the bottom, so the center part here that isn't cut doesn't go flying around the room like a missile. So they're going to be 8 millimeters long, 2.5 millimeters thick. Of course they'll be at the bottom. And I can just place these tabs where I want to. I'm going to put one there and one there, and I'm going to put 4 in. It's only small, but I will do it. And across to the other one. Put 1, 2, 3, 4. I don't like putting them in a curve because they're harder to clean up. Yeah, pretty simple. All right, close that. So we have all this sorted out. I'll make it smaller by pulling back on the scroll wheel so you can see what's going on. And again, a little bit more. Lovely. Do I want to add any ramps to the toolpath? Seeing I'm using a 1/4 inch end mill, which basically is a spiral up cutter, I don't think I need to do any ramping. They can cut down pretty well straight on their own. If I was using a straight 2-flute router cutter, well then I would ramp, because the cutters don't completely traverse across the bottom of the router cutter. They're on either side, and there's a bit of dumb metal in the middle, put it bluntly. We'll leave it as this name here. Down here you'll also see it says safe Z is 10 millimeters, which means as the Z axis, which is basically where the spindle or the router is going to be traveling up and down, when it's finished a cut, it will come up clear before it moves to the next vector to work on it. We don't want it to go down 18.2 millimeters and then just go to the other side. That'd be terrible, and I'd smash things. All right, so now we're going to say calculate all of that, which it's done, and it said we're going to go through the job, and I'm saying that's Jim Dandy. Here we go. Now, you can see down here that it's going to be starting over here, travel up 10 millimeters above the job, do this one first in 4 passes, then come up out of that 10 millimeters above, and then do this one over here. And we can do a preview. I'm going to slow the preview down so you can see how it happens. And I'm going to do a kind of, an animation of what it's going to do. Here we go. 1 and 2. So that's all cut. And then we're going to close. And I'm going to find out how long that job would have taken just by clicking on that. And it tells me 1 minute and 20 seconds, which is fine. Close that. And then now I'm going to save the toolpath. Well, before I save the toolpath, let's flip her over and have a look. So what I'm going to do is I'm going to drag it back to make it a bit smaller. This is on the scroll wheel. Drag it back towards me. Now I'm going to push down on the left-hand mouse button and push away from me. And it's rolling it over so I can see underneath. And that's lovely. If I click on this, that gets rid of the actual toolpath showing. So we can see it's cut out there. There's all the 4 tabs holding each one in. So I don't have any rockets flying around the workshop with me. And now I can click on this button up here, which says Z, and it's going to flip the thing back to looking from above. And now I'm going to click on this and say save that as an Avid CNC post-processor, and click on the save the toolpath. I'll save it to my stick and we'll be done.